If you'd like to talk about anything from this presentation with an AWS staff member, please come and find us at the AWS booth. Next up, we are honored to have Hugh Barrett, VP Technical Solution, CISSP, CSSLP, Telos, to share with us a case study on performing a security assessment of the cloud using the risk management framework.
Hello, hello. Can everyone hear me okay? All right. Like Alexa said, I'm Hugh Barrett, VP of Technical Solutions. I work for Telos Corporation. We're a partner with Amazon, and I'm here to talk about performing security assessments of the cloud using tools, best practices, and the risk management framework. So before I jump in, my presentation is going to be really revolve around the risk management framework and the NIST 853 set of controls. But as I'm doing this, keep in mind that you can substitute these controls with your own controls. So what I'm going to try and go through, and I'll try and get through this within the 35 minutes that was allotted to me. Let's set the stage. We're going to chat about the risk management framework, quick overview, talk about AirGap regions, assessment of the cloud, some common control provider themes, assessment of your workload, and then we're going to talk about the Exacta 360 tool, which is a tool that Telos offers to kind of help automate this cybersecurity process. Now, how many of you in here actually are in the cybersecurity discipline? All right. This will be of interest to you. It's a boring topic, but it's a necessary topic, right? So, the risk management framework, how do I say this? Back in the States, and I'm quite sure you all know I'm from the States, based on my accent, but back in the States, we have a couple of AirGap regions, the C2S region and the SC2S region. Those regions are owned and run by our government, and these regions are not connected to the public internet. These regions were built by Amazon, they're run by the government, and we had to assess these regions, meaning, you always hear Amazon talk about that their regions are very secure. From a government perspective, that's great. Trust but verify. We wanted to go out there and make sure that they were secured the way we wanted them to be secured. And when I say we, I'm talking on behalf of the government and on Telos. So we had to, we use the risk management framework to help us get through this. And I'm gonna run through the risk management framework, and I'm gonna talk about how we actually did this assessment to make sure that the region was secure, and then talk about how we secure those things that are gonna go into the region itself. So the risk management framework, is anyone familiar with NIST and the risk management framework? The risk management framework is a 6-step process. It's a very good process. It came out back in the early 2000s. NIST needed to have a standard that could be used by the entire government, right? And the motto was one government, one standard. And this opened the door up to reciprocity, meaning that if one agency had a system and another agency wanted to use that system, that agency should not have to go back and reassess that system, right? All done with the same standard. Everyone can accept everyone's results. So the first step of the RMF, or the risk management framework, was categorize your system. And it's a very important step, right? This is where we ask the system owner to tell us everything about your system, document the system, gather information about the system, tell us what mission that system supports, things of that nature. Step 2 was tailoring your controls and applying your overlays and applying your inheritance, right? So in step 2 of the RMF, you would determine what controls you're going to use by determining what type of data your system processes. Step 3, how does your system and your application implement each control? So based on step 2, you would pick, let's throw out a number, 855 controls. As a system owner, you had to go through and document how your system implements each one of these controls, right? We need to have that documentation so we have a way to validate whether or not you're meeting these controls. Step 4, assess the security controls. At that point, we have a group of individuals, we call them assessors. They go out there and they look at how you documented, how you implemented the controls, and they go out and test it to make sure that your system actually does what it says it was going to do, right? No difference than when you go through your typical application development life cycle. Step 5 was the risk management step, right? So the assessor assesses your control, finds out that something failed. The risk executive would go out there and determine whether or not that failure was anything significant, right? And that person had the ability to say, we're going to accept this risk, or you have to go back and fix this before we can deploy your system into the cloud or into your data center at that matter. Step 6 was continuously monitoring. So after step 5 and you did your risk assessment, they gave you the thumbs up. You got your, what we call your authorization to operate, or ATO. We would then continually monitor that system to make sure that it's meeting the same set of controls that it was meeting when we did the assessment, right? And we call that continuous monitoring. So we use this process to assess and certify that the Amazon AirGap regions that we have deployed for our government, and the section of our government that was using these AirGap regions was our intelligence community, right? We had to make sure that this thing met the controls and was secure enough for them to start putting their mission-critical workloads into this cloud. So just some more of the risk management framework, and these are some key words. I'm not going to really hawk on this too much. I want to get into the meat of the presentation, but the risk management framework is made up of 3 simple words, right? Or 3 simple keywords: confidentiality, integrity, and availability, right? So for every system in the government, we ask you to tell us how sensitive is this data, right? And you had to pick 3 choices: low sensitivity, moderate sensitivity, or high sensitivity or confidentiality. We also wanted to know, what is the impact to the system if this particular piece of information got out to the public, right? So that's how you determine your confidentiality of the system. The next thing we have to determine is the integrity of the system, right? And the integrity, again, is 3 simple values: low, moderate, or high. And integrity talks about how accurate is this data. If somebody was to change this data, would it adversely affect your mission, or could affect your healthcare or anything, right? And then we had availability. Again, 3 simple values. How available should this system be? Low, meaning that if the system goes down, the operation will still run, not a big deal. High availability means if the system went down, it was critical to the mission could not continue. And that's how you judge these 3 values, right? Everything in the risk management framework is based on confidentiality, integrity, and availability. So how does this work? Before I get into that, there's a couple of slides I added. I wanted to make a point here. So in the risk management framework, we have controls, and some people call them requirements. We call them controls. When we started, you had a control, let's AC1, for instance, and there were 10 things you had to do to test to make sure you meet that control, right? Can you imagine if one of these tests failed? Do you meet or don't meet the control, right? That was the problem we were having. So we decided to take that, this regulation, we broke it down a little further. So we got rid of the AC1 control, and we broke it down into 4 different controls, right? How many of you ever had to read any regulations and they said, well, make sure that your system does this and does this and does this and does this, right? That was too vague, right? We needed something that says, make sure your system does A. And the next one said, make sure your system does B. And we have test procedures on how to validate that. So now it was easier for us to say, if you fail AC1A1, you're good, you pass all the other 3. AC1A1 was not very critical, you can still pass that control, right? So we took it to a different level of granularity just so we can get that type of detail in our risk assessment. So this matrix represents how the RMF was used and how it works and how these confidentiality, integrity, and availability allow you to pick your control. So every single control, and again, you can replace these NIST controls with your own controls, right? Every single control has a value as to confidentiality, integrity, and availability, right? So if you see an X, anywhere you see an X, anytime your confidentiality, your integrity, or availability has that particular value, this control was applicable to your system, right? Everyone following that? So it's a mechanism or a formula for us to pick controls. The next thing we did in the RMF is you then have to identify all the different data types that your system processes, right? Does your system process, first name, last name, address? Does it process personal identifying information? Does it process financial information? Does it process, counterintelligence data, right? And you have to determine how important that particular data is based on confidentiality, integrity, and availability. Again, right? So you see those three words show up a lot. So if my system was processing financial data, the confidentiality of that data was moderate, the integrity of that data was high, but the availability was low, which means if the financial data wasn't around, business could continue as usual, right? If the financial data was altered in any way, it could have an adverse effect against my business. So that's how that was laid out. And that's how we determined to pick controls with the risk management framework. Now, I know you all in your government probably don't use the 853, but you could take your set of security controls and apply them to the same formula and be able to identify which controls you should deal with depending on the confidentiality and integrity of your system, right? There's another thing in the risk management framework. It's called an overlay. And overlays are very important. So I spoke about reciprocity, right? So if it's your Department of Defense, along with your intelligence community, along with your Health and Human Services divisions, all of you are using the RMF framework to do your assessments, but the defense folks, there's a set of controls that are different for them. So they would have a defense overlay, which they can apply to the controls, which would alter the controls based on defense. Health and Human Services may have to apply the privacy overlay, right? Because you don't want your healthcare data being leaked out to the public. So there's another set of overlays that'll show you how to better protect that data. But it's all based on the baseline of the CINA values, right? So we have those as well. And then we have the common control providers, right? Now, this is usually associated with enterprise systems, and you're going to see how we use that to actually accredit the Amazon AirGap regions that we use back in the States. But a common control provider allows you to quickly do assessments. So I always like to use the example of a DNS server that you can use to help authenticate and find hosts and so on and so forth. If your system is utilizing a DNS server and the DNS server was already assessed, then there's no need for you to reassess that. Inherit those controls and get the benefit of what that group did, and then you just move on. So common control providers reduce the amount of work associated with your assessment. It's a huge time saver, right? So the whole idea is if you go through these steps that I just mentioned as you're going through the RMF and RMF risk management framework, at the end of the day, you'll have a list of controls that you need to assess your system against. This happens to be the screen from our product that shows you all your applicable controls and shows you what overlays are available for you. So now let's touch on the isolated region. Like I said before, there were two isolated regions that we had in the States, right? One was our C2S, and one was the SC2S, top secret region. We got called in by our government to help them assess the SC2S, right? They wanted to start up another AirGap region. Amazon set up the data center, or set up the cloud, and they then had to assess it, right? Like I said before, trust but verify. Amazon said their regions are very secure. The government says, yeah, but I need to check it anyway. So they called us in, and they said, we need help doing this assessment. And the reason they called us in was the first time they assessed the one that had the check mark, AirGap Cloud 1, it took them almost 2 years to get through that assessment, right? Now they're starting up a new AirGap region, and they did not want it to take 2 years. Matter of fact, they only had 4 months to get it done. And They know they couldn't do it manually because the manual way was to take those charts and those matrices that I showed you and put them into a spreadsheet and use spreadsheets in a Word document to try to get this assessment done. So they call us in and, you know, before I go, so is everyone here familiar with what an AirGap region is? Is anyone not familiar with what an AirGap region is? Okay. I should have asked a negative question. So an AirGap region is, everybody's familiar with Amazon Cloud, right? Okay, just checking. So the Amazon Cloud that you're used to using is not an AirGap cloud, right? You can get onto your browser, log onto the hotel internet, and you can access your EC2 instance up in the cloud, right? In an AirGap region, you can never do that. That region is not connected to the internet. Physically disconnected, isolated region. And it's done for a reason, right? The owner of that region, I should say the person who leases that region, because Amazon owns that region, they have complete control over who has access to it, right? Complete control over what workloads go into that region. They have the ability to enforce a process for vetting any workload that's going into that region. And they have the ability to take advantage of all the AWS cloud, what the AWS cloud has to offer. And I can tell you, I don't know about the Singapore government, but the US government, if I wanted to stand up an application and it required me to get 2 servers, that could take 6 months. Right, just to get the 2 servers, and then it could take another 6 months to get them to approve my application. You know, with the cloud, I fire up an EC2 instance, I load up my application, I put it through the assessment process, and I'm up and running. That's one of the beauties of the cloud. And the fact that it's AirGap and it's owned by an agency, they have a lot more control. They have a lot more freedom into allowing you to start up and shut down these regions, these instances. So, in doing the assessment, we realized, like I told you before, the first cloud took a couple of years. The next cloud could not take that long. So we had to use some automation. So that, like I said, they came to us. They said, hey, we need your help. We have a tool, Exacta 360, and another tool called Exacta Continuum. These tools are designed to take in any one standard, international standard, domestic standard, anything, and run that standard through an assessment process and come out at the end with a risk assessment fully baked. So they needed to define a process, because the first time they did it, there was no process. They needed a way to enforce that process. They also needed a way to collaborate with Amazon in doing this compliance of that cloud. They need to apply risk management. They wanted something that would apply the risk management framework and then support multiple standards, right? Believe it or not, before the risk management framework came about from NIST, a lot of the different agencies in the government was using different standards. Very hard to move systems around when somebody's assessing against ISO, the other person is assessing against, DSCID, somebody else is assessing against the RMF. So we support the multiple standards, we map all those standards together, but it was a lot easier when it's just one standard. And support multiple standards. One more thing I want to say about that. In our product, we have a way to map standards. So if I was to do an assessment using the RMF framework, and I had to give you that assessment, and you're using the Singapore regulation, we can map those regulations one-to-one, and you can take my assessment, and it'll get applied to your set of controls, and you can just look at how things stack up against your regulation versus the regulation that we're using. Very powerful feature, used a lot by several of our agencies, just so they can achieve what we call reciprocity. All right, so what do we have to do to assess this new cloud region that was coming online, right? The AirGap region. And everybody remember what AirGap means now, right? So we had to get detailed documentation of the region. So we had to go out to Amazon, and Amazon had to tell us everything about the region. If you went to Amazon and asked them that question, they'd probably tell you to drop dead, right? But, when you're waving hundreds of millions of dollars, they detailed it. They gave us detailed document about the region. A categorization of the data that will be processed. We sat down and we said, okay, here's all the data that will be processed in this region. intelligence data, mission data, targeting data, XYZ data. And we identified every single data, and we used what they call the NIST 860 to identify the CINA values of each of those individual data types. That took some while, but we got through it. Then to select the controls and overlays, based on that CIA value, we were able to select all the controls, and it came out to about 855 controls that we had to then assess against. Needed a detailed description of how the AirGap region met each control. So we sat with Amazon, and Amazon sat with their service team, and they, for every single control, how do you handle passwords? They documented how they handle passwords. How do you handle encryption? They documented how you handle encryptions. How you handle KMS keys, who gets to do that? You know, all of that was laid out for us. Something that they would normally not tell you know, an average person, right? Because that's Amazon's proprietary information, and we have to treat it as such, right? So we don't go talking about that. But we needed that because we had to verify that what they told us was how things worked. So for each implementation, then we had to independently assess to make sure that what they said it did, it actually really did. And then we had the government leadership had to go through and look at any areas where there were deficiencies, if there were any, and determine whether or not they wanted to accept the risk or have Amazon fix the problem so that they can get the region to a point of a secure level. So, you know, we went through those steps, and like I said, we got through this assessment in roughly about 4 months of an entire region. So with that, you know, I can stand up here and tell you that Amazon's regions are very secure because we didn't find anything, right? So the way we did it, so, you know, we looked at the Amazon infrastructure, and we applied all those controls, and we assessed everything about the infrastructure. The buildings, you know, the power, the air conditioning. Is there a guard at the front? Does the guard have a gun? Is there a guard dog? All of that we went through. And we came up with about 856 controls that we had to test for that infrastructure layer of Amazon, right? After that, we generated what we call a security package. And a security package is just documentation about how the region stacks up from a security perspective, how it met each of the controls, which ones it passed, which ones it didn't pass, what were the risks, so on and so forth. After we got the infrastructure layer done, the next thing we had to do was identify, out of those 856 controls, how many of those controls actually could be inherited, right? So, for instance, I don't know if any of you ever seen an Amazon data center. They're pretty impressive. There's a bunch of controls in the NIST framework called physical controls, right? And these are things like, is there a camera outside the building? Are the cameras X amount of feet apart? You know, is there a cooling system? Is there a backup power? Is there a guard? All the physical controls, right? Anything you would expect from any data center where you're going to put your workloads. So we identified controls similar to that, and we would say, okay, if you're going to put your workload in the Amazon cloud, you don't have to worry about power, cooling, space, because they take care of that. So that's a control you can inherit and use right away, right? So if your application has to meet the PE controls, you're done. Amazon did them for you. You get them for free. After we went through and did all the analysis of the controls, after we did the assessment of that infrastructure layer of Amazon, we came up with about 737 controls that were inheritable, right? That's great news, and you'll see why. The second part of the assessment, we had to now assess all of the different services that were going to go into this AirGap region, right? And when I say services, I mean things like IAM, EC2, you know, VPC, directory services, workspaces, all those are services, right? Consumer-facing services. Well, not only did we have to assess the infrastructure, we had to assess every single one of those services individually against the same 856 controls, right? Because we determined that we wanted to be at this particular security level with the cloud, because these are the different data types that we were going to be putting in the cloud. So 856 minus 737. So for each one of the services, instead of having to go through and do 856 controls, we only had to do 119 controls because the other 737 controls we inherited from the infrastructure, right? So although it took us, let's say, it took us 2 months to assess that infrastructure layer, it took us weeks to do each of the services because now we are only responsible for 119 controls, right? And again, in your own environment, replace our controls with your controls, but the same formula, the same technique works. And then we had the security packages, and that was all the security assessment of the cloud, right? Now, all of those security packages made up what we call providers, right? Provider projects. So now when you want to put your workload in the cloud, we identified from each of those services which controls they can share out to workloads. So when you do your workload, your consumer workload now inherits that, right? And I would hope that every one of you, if you're going to put a workload in the cloud, you would go through the drill of determining whether or not that workload is of any security risks, right? And you should take it through an assessment of its own. But anytime there is a control that Amazon is providing for you, that Amazon says is already good, is a control that you don't have to do, right? So then we had to go back and implement the Amazon shared responsibility model. And that shared responsibility model says that Amazon will take care of a piece of the security, and you have to take care of a piece of the security. And that's what this is all about, right? The black layer is Amazon taking care of their part of the security, and the blue layer is you taking care of your part of it, right? So now when you're assessing your workload to put into the cloud, if you notice, the steps to assess the workload is really no different than the steps we went through to assess the cloud itself, right? Should be no different. You're following one standard. Everybody's marching to the same tune. Again, so now instead of starting with the Amazon infrastructure, you're starting with the Amazon consumer services, right? You're putting a workload into the cloud. You're going to utilize EC2. You may utilize IAM. You may use KMS because you're doing some encryption. Then you have your workload, and these are the services that your workload is utilizing, right? IAM, S3, RDS, workspaces, so on and so forth. These are the actual controls that your workload is going to be assessed against, and these are the controls that Amazon, from a consumer perspective, is providing to you, right? And the number of controls that you inherit varies from service to service. Like, if you had a requirement where your system has to make sure it audits XYZ, CloudTrail does auditing for you, right? So part of the auditing is done by CloudTrail, and your system has to do their part of the auditing. So those two together, it identifies a shared responsibility model. And then you have your security baseline for your workloads. Then we go into continuous monitoring, right? And the way we do continuous monitoring, there's a bunch of tools that are out there. We had our Continuum tool. You remember I mentioned that earlier. That tool allows us to pull in things like your Nessus scans, App Detective, Web Inspect. All that comes into Continuum. Continuum sends that over to our other Exacta 360 tool, and it starts continually monitoring these controls. So, Exacta can go against CloudTrail. It can go against the IAM logs. It can look at your EC2s. It can make sure that all of your settings and configurations are the way they should be based on your initial assessment. And we just keep monitoring that. And if anything changes, we'll alert you. But more importantly, we will update documentation for you, right? When you're using our tool, documentation is not something you should worry about. But when you're doing an assessment, your auditors, the first thing they want to see is the documentation, right? So when you have an automated tool, when they say, I want to see the documentation, that's when you go back and you push the button, and it just generates the documentation for you. Other than that, you shouldn't generate that documentation. If you want to know which controls are failing, you go into your automated tool, you run the fail, control report, and it gives you a report, right? So I'm going to take the last 6 minutes and talk about our product, because it's a tool you should use when you're using this, by the way. Exacta 360, right? Everything I just talked about it supports. Matter of fact, it was the tool that we use to do the assessment. Like I told you before, when the government did their assessment of the first cloud, they didn't use this tool. It took them 2 years. When they did the assessment of the second cloud, they used this tool. It took them 4 months, right? Easy math. I won't even do it because I probably can't. No. Out the box, Xacta supports a lot of international standards, ISO, NIST, cybersecurity framework, you name it. I mean, literally, we take controls and we apply controls to assets, and we tell you where you're failing or not failing controls. Just a couple of walkthrough of some screens so that you can see it, right? You remember I talked about the information types or your data types where you have to identify what type of data your application is processing? We have a list of them here, right? And the RMF has a documentation set that lists all of the different data types and what they perceive the CI and A value should be. You can change this if you want. Control sets, we allow you to pick which controls you want to use. Right now for us, since this tool is being used for US government purposes, we have US government regs in here, but if you look at our library of regs, we have 256 different regs. We have ISO, cybersecurity framework, we have defense regs, intelligence regs, HIPAA for healthcare. A lot of different regulations are built into it. Here you have an inheritance questionnaire. Can you imagine if you were going to put a workload in the cloud and you have to all you have to do is go through and say, oh yeah, I'm using EC2, I'm using IAM, and we just automatically say, here are the controls that Amazon is going to give to you, and here you don't have to worry about them. That's what this does for you. And then we have an automated screen that allows you to document how you're implementing these controls. And then we have a screen for the assessors, the person that's going to go out there and test and validate each one of these controls. They can go into the tool, go through each control, look at all the information that you put in, and then determine whether or not you pass or fail that control. Very important piece that has to be done, right? And we go through a lot of other things. If you want to really see how this works and talk more about what we have done, we have a booth across the hall in the Expo Center. Stop by, we can chat. For those of you who are interested in the RMF, and like I said before, I know a lot of people say, hey, well, you know, that's a US standard, we don't want to use it. Remove our controls and put your own in there, and that framework actually is so granular. It actually gets to the meat of where the problems are when you're trying to assess a system. So these are the documents that make up the RMF, the ones that, you know, if you really want to learn more about what I was talking about, read through these documents, the 37, which talks about the framework, the 53, which is all the controls. And I can tell you, I've seen a lot of controls. Your controls, our controls, you know, the controls in Canada, the controls in Mexico, they all say the same thing, right? Passwords, audit, pick them, you name it. So a control is a control. And then you have the 860, which is the document that is of a lot of interest. That talks about how you categorize data that the system is going to process. And if you know what data your system is going to process, you can better understand what controls and the stringency of those controls that you need to apply to that system, right? You know, a lot of people will tell you that this is a pretty, you know, drawn out, tedious process. It's not the sexiest part of the cybersecurity discipline, but it's probably the most necessary, right? Has any of you ever been hacked? Any of your systems ever been hacked before? I won't ask that question again then. You know, when a system gets hacked, the first thing, at least in the States, the first thing we do, we go to this type of data to find out what controls were levied, which ones it didn't pass, which ones were risk accepted, which ones had outstanding mitigations that needed to be done. Because when that happens, we need to go back there to find out where we are. And more importantly, we need to find out what mission that system was serving, right? If that system that got hacked was, you know, if it was our missile targeting system, that's something you need to deal with right away. If the system got hacked was the system down in the, you know, Department of Defense gym where the soldiers work out, we can let that one sleep for a little while and we'll get to it whenever we can. So it's good to have this type of data, right? Any developers in the room? So, you probably wouldn't write code if they didn't give you the actual requirements written down, would you? The same thing holds true. You wouldn't want to assess a system or put a system into your network without understanding all of the details about that system. So that was my last slide. Again, I know I went through this very quickly. If you have any questions, come across the hall. We're there. We can chat with you and give you a demo, explain the RMF in more detail to you. All right? Thanks a lot.